Mindsetters, welcome to today's Grade 12 Life Sciences show. Today we have a special revision lesson on the endocrine system. We have selected highlights from lessons shown earlier in the term to help you revise. Please post your comments and questions on our Facebook page on facebook.com/learnextra or on Twitter @learnextra so we can help you with your revision. You can also download the notes for today's show from learn.mindset.co.za or click on the link on our Facebook page. Now it's time to get on with today's lesson.
Now we go to the summary. We start with endocrine and exocrine glands because our statement said we must know the difference between endocrine and exocrine glands. Guys, can you help me out? Difference between endocrine and exocrine glands.
The endocrine gland, it secretes straight in the blood. It has no ducts.
Endocrine gland secretes directly into the blood. So you're saying it is ductless. Good. Exocrine? Roy?
The exocrine secretes straight to the not the intestine.
Where? This one was ductless. So this one?
Straight with the duct.
In the duct.
In the
Good.
duct.
So this one here will secrete into the duct. And the duct will take it where it needs to go. For example, you were talking about the intestine. How does that work? The intestine secretes intestinal juice, and this will go into the hepatopancreatic duct, into the duodenum, and it will be secreted there. For example, the liver secretes bile. Bile then goes into the bile duct, common bile duct, and it goes that way. So that's what we are talking about. Now, interesting, people, is the pancreas. The pancreas acts as both endocrine and exocrine. Why do we say that? Because it secretes pancreatic juice into the pancreatic duct there. And this pancreatic duct will take the pancreatic juice to the hepatopancreatic duct, which will end up in the duodenum. Good? At the same time, inside the pancreas are cells known as the islet cells or the islets of Langerhans. And these islets of Langerhans secrete insulin and glucagon directly into the blood. So in this case, the pancreas is also known as an endocrine gland. Thereafter, and this is something you should get used to in your own schools, draw the diagram of the body. It doesn't have to be a perfect diagram of the body. Label the glands in a particular color or colors. And then write down the names of the hormones in another color. And thereafter, you can talk about the functions of the hormones in another color. And we start on the top there, the hypothalamus. Secretes ADH. ADH. Remember this, you may get confused. You may say that the pituitary secretes ADH, but it's not the pituitary, it is the hypothalamus. But the hypothalamus secretes this ADH and it is stored in the pituitary gland. The pituitary gland will release the ADH, not secrete, but release the ADH. Remember when you did nutrition, you spoke about bile. Bile was secreted by the liver, but released by the gallbladder. Good? Okay, so that one there secretes ADH, and notice the function, osmoregulation. What is osmoregulation, guys?
Control of
Control?
water in the body.
Water in the body. Control of water in the body. Good. Osmo water regulation, the control of. In other words, ADH will help us to control the amount of water in our blood. Pituitary gland, and this one I'm going to go through very quickly because summary, secretes GH, growth hormone, which obviously is there for growth and development, mainly of the long bones of the skeleton. TSH, and I read the name earlier, thyroid stimulating hormone, will stimulate the thyroid gland to secrete thyroxine. Follicle stimulating hormone, you should all know this from reproduction, stimulates the development of the follicle. LH, also from reproduction, triggers ovulation, and as a result, leads to the formation of the corpus luteum. Prolactin, the lactin coming from lactose, stimulates milk production in pregnant women and thereafter when they give birth. The parathyroid gland, we are not going to worry for exam purposes, but they secrete hormone which help us in calcium reabsorption. Among ladies, among females, Luni, this is very important because when they fall pregnant, the developing fetus takes a lot of calcium out of them.
Yeah.
Now, what happens among you young ladies is that you do not take in enough calcium. When you get older, you're going to suffer from osteoporosis because of that. Not you're going to, you may suffer from that if your calcium intake, and at your ages, you should be taking as much calcium as possible. We are interested in the thyroid glands. Notice where it's found. It is found over the larynx. Secretes only one hormone, the thyroxine. It controls the metabolic rate. It affects the growth and development with growth hormone. It also affects the functioning of the heart and the nervous system. A little below that is the thymus, helps to build resistance to disease. Again, these two not for exam purposes. We have the pancreas, which is there for exam purposes, insulin and glucagon. Insulin, does it reduce or increase the blood sugar level? Nadia?
Increase.
Increase, is that correct, Roy?
Yes, sir.
It's correct. Amukhalan?
So it decreases.
It decreases, right? Bong, bong. And Amukhalan gets it right. It decreases the blood sugar level. How does it do that? It converts glucose into glycogen and fat to be stored in the liver, and or it also stimulates the cells to absorb more glucose so you can use the glucose. Okay? And glucagon obviously then raises the blood sugar level by converting glycogen to glucose. Okay? Then we go to the ovaries. We're not going to the ovaries, but we're looking at the ovaries. And the ovaries secrete estrogen and progesterone. Estrogen and progesterone. You know the functions of estrogen and progesterone already. The testes secretes testosterone. You know the functions of testosterone already. On the other side, we have the adrenal gland. Notice it's labeled on the other side. It's not on the other side. It's above each kidney. We find the adrenal glands. The adrenal glands secrete adrenaline and aldosterone. Adrenaline, I'm not going to go through all the functions of adrenaline. We'll ask the learners to help us just now. Adrenaline prepares the body for emergencies. We'll leave it at that. And aldosterone regulates the salt content in the body. You can see that aldosterone and ADH have to work together, because when we want to reabsorb water, we need to decrease the water potential. And one way of decreasing water potential is to add salts. So aldosterone and ADH have to work together. Tell me, guys, about this emergency. How does adrenaline prepare us for emergency? Give me one, Roy, first.
It increases your heart rate.
You've got to speak a bit louder for me, Roy.
It increases your heart rate maybe in an emergency.
It increases the heart rate in an emergency. Now let's look at that. Heart rate is beating faster. That means the heart is beating faster. What does this do? It improves circulation, and therefore oxygen is reaching the cells faster and carbon dioxide is being removed. Good. And another one, Amokhanan.
It
You must
incre-
talk loud, right?
It increases the breathing rate.
It increases the breathing rate. Obvious, if you want to send oxygen to the cell faster, then you have to breathe more oxygen in. Now guys, this section, this one about adrenaline, sympathetic nervous system also has the same function. You don't have to learn it. You have to think it. Because when you're excited, when you're anxious, when you are scared, when that snake is running behind you, or when they announce, Roy, get to Mr. Khan's office in the next 1 minute, then you know what's happening in your body at that time. Okay? So those are the things that's happening. Nadia, give us one.
Increase glucose level in the blood.
Okay, she says it increases glucose level in the blood. Why? We need energy to react. We also talk of the adrenaline hormone as the fight or flight. Fight or flight. Fight, you stand there and you fight. If that snake is coming, you're fighting the snake. Or when you see that snake, you turn around and you run like hell so that the snake mustn't catch you. So because of this, that's important. In addition to this, the blood supply to the heart and to the skeletal muscles is increased. How? These blood vessels dilate. So more blood goes to these spots. Why? Because you need to run like hell, or you need to fight like hell. So you need these things to be working for you. At the same time, blood vessels to the skin and digestive system, they constrict, because you don't need blood to go and cause digestion to happen at that time. You're too scared, you're too excited for that to happen. So those are some of the logical things. Last but not least, the dilation of the pupil, which causes more light to enter the eye, and we can see clearer that way. And that brings us to the negative feedback mechanism. What is a negative feedback mechanism? It's a mechanism that ensures that in any control system, changes that occur are reversed and returned back to the set level. How? Where a response by the effector is opposite to and reverses the stimulus. So there's a stimulus, more glucose in the body. The control center picks this up and decreases the blood sugar level or glucose level to normal. This is what a negative feedback mechanism has done. So you must understand that a negative feedback mechanism is a mechanism in which the response is usually the opposite to and reverses the original stimulus, whatever that stimulus is. In our situation, we're either going to talk about too much or too little of something. If the stimulus was too much, the negative feedback mechanism will decrease back to normal. If it's too little, the negative feedback mechanism will increase that substance back to normal. It's all about balance. And this balance we'll talk more about next week when we talk about homeostasis. Still carrying on with our summary, the interaction between pituitary gland and thyroxine. Here's an example of a negative feedback mechanism. If this is the normal level there of thyroxine, if for some reason it is elevated, by the way, for you OBE learners, elevated means increasing, okay? If it's increased for some reason, the thyroxine level is increased, it stimulates the control center. Which is the control center? The pituitary gland. What does pituitary gland do? It secretes less TSH. And if it secretes less TSH, then it is going to stimulate the thyroid gland less or more?
Yes.
Less, obvious. Okay? So the thyroid gland is not stimulated so much. So the amount of thyroxine is less or decreases. Decreases to what? To the normal level again. And the opposite is true. If the thyroxine level is low for some reason, then the pituitary gland, remember the control center is the same, whether it's low or high. What does it do? It secretes more TSH. Don't just write it secretes TSH. You must talk about more or less. This section is all about that when we're talking about negative feedback. And therefore the thyroid gland is stimulated more. And therefore it secretes more thyroxine and the level comes back to normal. A very simple flow chart there. I want you to take a moment just to look at that. I'm giving you 2 seconds just to look at that and try and absorb it. Obviously it's on your study notes as well, so you will see it again. The first question says, and guys, you've got to be on your toes now, just like this lady on the toes, there, on top there. Study the diagrams below and answer the questions that follow. They give you a diagram here. There's a snake there, and this lady is screaming for help and so on. And this one here, he's running, diagram 2, he's just running. And this is diagram 3, just giving you the normal body there. They want to know how will the diameter of the skin capillaries of the person in diagram 1 compare with those of diagram 2. Diagram 1, skin capillary, and diagram 2, skin capillary. This question is not restricted to endocrine system. What has been added to this one? What other section? Homeostasis. Excellent, Amohalang. Well done. So we're talking about homeostasis as well, and which part of homeostasis? Thermoregulation. In an exam, expect this. Don't think that one question will deal with one section only. So they want to know, compare the diameter of this one here who is sweating and this one here who may also be sweating of fear. But so what can we tell us, Roy?
The diameter of the diagram 1 will, I think, will open more to allow more sweat.
In diagram 1,
Yes,
you're saying it's dilated.
dilated.
And this one, constricted.
It will constrict.
Amukhalang, you agree with it?
I guess.
You agree? Nadia?
No,
You don't agree. What would you say?
I would say the diagram 2 would dilate.
Diagram 2 will dilate and this one will constrict. Luni, you want to be the judge?
It's
You can't be the
fine.
judge. I must be
No.
the judge.
Yes.
Okay, let's look at it carefully. This person here is an emergency. Remember? Emergency. And what did we say about an emergency? Do we need blood to go to the skin? No. Yes? So what must happen here? It must constrict. And this one, the person is sweating. How come they're sweating? Because more blood is going to the skin. Why? Because it's hot and they're running. They're running, so they're sweating. So that means this one must be dilated. Nadia, you get full marks for that one. Right? Narrower in diagram 1 and wider in diagram 2, or we use the correct words. Try not to use narrower and wider, use the words constricted and dilated. That's the correct words. And don't ever use big and small. What is big and small? Big can be big like that and small like this, or wider or narrow. So don't use big and small. And don't use thin and thick either. You either use wider or narrower or constricted and dilated. The best, constricted and dilated. Choose the letter of the gland in diagram 3. In diagram 3, that can be associated with the condition of the skin capillaries in a person on diagram 1. Listen to the question. Which gland in diagram 3 is associated with the condition with the person in diagram 1? What was the condition here? Emergency? So which gland is involved in emergencies?
D.
Adrenal.
Adrenal gland, good. And that is letter
D.
D. Okay, so that's an easy one. Answer is correct. Explain your answer in question 1.2 by referring to the changes that occur in the diameter of the skin capillaries in a person in diagram 1. Now we need to explain what happens to this person. Okay, and that's easy. We've done it already. First of all, we name the gland, adrenal gland. What does it do? It secretes adrenaline. Look at the marks, how they're going to go here, right? One is we identifying the gland. Secondly, we're telling you what it's secreting. Thirdly, we say it goes to the skin capillaries, causing them to constrict. Why? So that less blood flows to the skin. Why? So that more blood can be directed to the strategic organs. Which are the strategic organs? We can give examples. The skeletal muscles, the brain, the heart. Why? To provide more fuel and oxygen, to provide more energy to deal with the emergency situation. You need to start thinking in this way, where your answers is in the step line. You don't always have to write it like that, but you must think in that way, that this is where my marks are coming from. Are we okay with this one, guys?
Yes.
Make it easy for you. Give the letter of the diagram again, or the gland, not the diagram, the gland in diagram 3 that will be affected first if the metabolic rate of the person in diagram 2 needs to be lowered at the end of a race. So at the end of the race, we want the metabolic rate to come down. Which of the glands will be affected first? So the stimulus is that the metabolic rate is high. Which is the control center for that?
Thyroid.
Thyroid gland? Is that the control center?
No.
No. Which is the control center?
Pituitary.
The pituitary gland. And in this diagram, which
A.
one is it? Could be A, no? Am I right? Base of the brain there. Okay? Let's see if I was right. If I'm wrong, 2 cuts for me. Okay, so I was right. But I wrote the question, so I can't be wrong, right, Roy?
Yes, sir.
I can be, you're lying. Explain the role played by the gland named in question 1.4 in lowering the metabolic rate. Now, how does it do that? Simple. It will secrete. What are we talking about, by the way? What mechanism is this? Negative feedback. You must talk louder, guys. Huh? Negative feedback. So what will it do? We already named the gland there A. What was it called? We didn't name it, sorry. Pituitary gland. What will it do? It will secrete less TSH. Why? This will lead to less stimulation of the thyroid, so less thyroid activity. What will this do? It will secrete less thyroxine, and therefore there will be less thyroxine, so the metabolic rate will decrease. So notice, guys, in this question, they didn't ask you what will happen if there's less thyroxine, which is a straightforward question. They took the function of thyroxine and told you that that function was high. How can that function be high if thyroxine is high? So, same question. Our answer would be the same if I asked it about thyroxine or this. Can you understand what we're saying here, guys?
Okay, guys, I hope you are enjoying this revision session. If you need help, remember to post on the page or send an email to helpdesk@learnextra.co.za. Now it's time to take a quick break, but don't go away. We'll be right back. Welcome back, guys. We have some great news to pass on to you. We will be bringing you winter school from the 30th of June till the 20th of July, starting at 10 a.m. every weekday. To get the full schedule, visit our website, learn.mindset.co.za, and look for the winter school link. Join us. It's going to be a lot of fun. But now it's time to get back to the lesson.
Answer the following questions on hormones. 2.1. Name the endocrine gland which secretes each of the following. This is a straightforward level 1 question you need to recall. Name the endocrine gland which secretes each of the following. TSH. Roy. Pituitary gland. Come, you got it right. Adrenaline. Amakhalang. Sorry?
Adrenal gland.
Adrenal gland. Excellent. Thyroxine, Nadia.
Thyroid gland.
Thyroid gland. Hey, these guys are sharp from Amatimone. They must be got a good teacher there, Luni.
Obviously.
I wonder who's that teacher. We have to find out. We must phone him.
Yeah.
One day we'll call him to the show. Growth hormone. Roy.
Pituitary gland
Hey,
also.
pituitary gland. You see, they know. Aldosterone. Nadia.
Adrenal gland.
See, I even caught her. I went past her. She still went you the answer. Yes?
So
I didn't
clever.
train them. Adrenal gland. Good. Excellent. So guys, this is a straightforward question. They can even give it to you with a diagram. They can say, give the letter and the name of the gland that secretes all of this. Then you have to give the letter and the name of the gland because it's worth 2 marks. Most of you either give the letter or the name. You lose half the marks unnecessarily. You must give both. Follow instructions. It was found that the thyroxine concentration of a healthy adult, that means we're telling you everything else is normal with this person, remained low for a period of 3 months. So, thyroxine was what? Low, na? What did they say? Low for a period of 3 months. Now, I already led to this question earlier. I didn't even know this question was here. Will the person gain or lose weight if he continued with his normal diet through this period? He will gain weight. Yes, good. He will gain weight. Why? Because thyroxine level is low, the metabolic rate will be low, so therefore he won't be burning the food, he will be saving the food, and this is going to add on to his weight. Explain. Man, I'm so silly. I gave you the answer. I didn't read that. You must stop me when you see I'm talking too much, right? Explain your answer, okay? I gave you the answer already there, right? Good? We don't have to discuss that. Everybody with me? Good. So much nicer when we have pupils here, Luni.
Yes.
Now we come to an essay question. And guys, I'm getting lots of WhatsApp messages on my WhatsApp and on my Facebook page. I'm talking my personal ones now, where children are asking me, so sir, what do you think the essay is going to be for June? I'm not going to tell you, even if I knew, I wouldn't tell you, because then I'm not teaching you anything. I must teach you how to ride the bicycle. I mustn't tell you the bicycle has a pedal and it has a steering and you're going to be riding this bicycle. That's not going to help you. You must learn how to ride the bicycle. So in the same way, you must learn how to write an essay and you must learn the work, the content. Learning the skill and the content, you put them together, you are sharp. So all the essays that we do here are practice for you to write essays. So let's look at this essay. The nervous and endocrine systems help to protect the human body. Use suitable examples to describe how this is achieved through a reflex action and by the hormone adrenaline. Now, mindset is you will remember that previously we have discussed part of this essay already in this forum, but up to here, when we did the reflex action. Now I'm showing you, this is actually a question that appeared November 2012 in the national paper. What have they done? They put the endocrine system and the nervous system together to give you the essay. What must we do? Again, guys, remind me, what must we do when we get an essay question? What must we look for?
The verb.
We must first and foremost look for the verb and other keywords. But the verb is important because the verb is telling you what to do. And here they say, all this up to here, they're not telling you to do anything else. From here they're telling you, use a suitable example. To what? To describe how this is achieved. How? By a reflex and adrenaline. So basically they're telling you to describe a reflex action and the functions of adrenaline. That's all. That's all we needed to do in this essay. So let's see how this answer panned out. They're telling you about the reflex action. Giving you an example. Remember, the example of a reflex action is not touching a hot plate or poking yourself. It's when you pull your hand away from that area. Okay? They're giving you the whole story, and we've done this on the nervous system already. Notice the logical flow from the beginning to the end. They don't talk about receptors and then say you pull your hand away and then says it goes to the sensory neuron. There must be a logical flow. Then, action of adrenaline. All they have done here is given you an example. You're getting, there, I like my famous, Roy knows why I put this one here, because they all shake when I say, Roy, get to my office now. They all get very scared. Or any other suitable example. And they're giving you the functions of adrenaline. That's what they do there. And what are you going to get marks for? Relevance, logic, and comprehensive. Relevance, if you didn't talk about anything else. You only spoke about the reflex arc. You didn't talk about the brain and the cerebrum and the cerebellum and anything else. And adrenaline, and you didn't talk about thyroxine and the rest of it. Relevance, you'll get 1 mark. Logic, if it flowed. You did one thing at a time, and you went from step to step, logic. Comprehensiveness means that you said everything that there was about adrenaline, and you said everything there was about the reflex action. And that is how you get your marks in an essay question, guys. Let's move on to the summary. Summary starts with our acrobatic man, much like me, Kawan. What's that, Luli?
No, you would be
I do
upside
the other way
down.
around.
Yes.
I thought you'd tell me that. Oh, what are we seeing there? We're seeing clearly the man trying to balance, and homeostasis is all a balancing act. You'll notice in your answers for homeostasis, your last sentence will always bring it back to normal. Whether it's going up, it must come down. If it's going down, it must come up. What? Where? Balance. That's what we're talking about. What is the internal environment that we're talking about? It's the tissue fluid. Now, let's look at this particular diagram. There's an arteriole on one end and a venule on the other end there. I used the wrong colors in the wrong space, but you know what we're talking about there. In this area, there's pressure build up because the artery or the arteriole is under pressure from the heart, because the heart is pumping blood into the artery. The arteries become arterioles, and then they become capillary. Here's your capillaries here. On the venule end, there's nothing pumping the blood. The blood is flowing slowly back to the heart. So there's pressure here. There's more blood coming in here and less blood going out there. So what happens? Some of this blood, some components of this blood leaks out of the blood vessels, and this green that you're seeing all over there by the cells, the fluid it makes. It's not green in your body. Okay? This fluid we call tissue fluid. This is how tissue fluid forms, and you would have learned this under this section in grade 10, the lymphatic system. What are those factors that we need to control? There's a list of them. carbon dioxide, oxygen, urea, salts, glucose, water, temperature, and pH among the more important ones. These things have to be kept constant in the tissue fluid. If they go off, there will be problems. We'll talk about that in the questions. Negative feedback mechanism, and this one is showing you the one with carbon dioxide. Notice the mechanism that is involved is nothing new. All we have done is we've substituted words where we spoke about thyroxine and thyroid gland and pituitary gland last week. Now we're talking about other parts of the body. You must remember there must be a stimulus, there must be a control center, and there must be a response. In any not only negative feedback, but in any coordinating system, these three things are very important. There must be a stimulus. Any change in the environment, stimulus. There must be a control center. It must be fed to a control center. And the control center must initiate a response somewhere. How does it happen here? Let's say for some reason, the blood carbon dioxide levels fall, the pH, let's start here, sorry. If this is the normal carbon dioxide and blood pH, why do they talk about carbon dioxide and blood pH together? For your exams, it's not that important, but why do they put these things together? Simple. If carbon dioxide levels increase in the blood, the carbon dioxide breaks up into carbonic acid and bicarbonate ions. This carbonic acid will affect the pH. Okay? So that's why we're talking about that. So if the carbon dioxide is normal, and for some reason the carbon dioxide increases above the norm, what will happen? First of all, these things here we can talk about as an extra order. Diseases raises carbon dioxide level. Some diseases can cause the carbon dioxide to increase. But carbon dioxide does not have to wait for that. You could be exercising, you could be running a marathon. Because the oxygen is not getting there fast enough and your carbon dioxide is not being released quick enough, your carbon dioxide levels will increase. What does this do? It drops the pH levels in the blood. What does this do? It's picked up by chemoreceptors in the carotid artery and in the medulla oblongata. So the medulla then is your control center. This is where it's fed to. And what does it do? It stimulates the increased rate and depth of breathing. And it can also stimulate a faster heartbeat. So what's happening? You're breathing in faster, so you're getting in new oxygen and you're getting rid of carbon dioxide. And if your your heart is pumping faster, your circulation is improved, so oxygen gets to the cells faster and carbon dioxide is removed. And in this way, there's an increased removal of carbon dioxide from the body, and the blood carbon dioxide levels comes back to normal. That's what happens. So we don't talk of much of a decrease in carbon dioxide in this negative feedback mechanism. We mainly talk about an increase. The problem with this is a slightest increase in carbon dioxide lowers the pH. And if the pH is affected, Kawe, what's the problem?
The enzymes.
The enzymes would be denatured because enzymes are specific to pH. And if the enzymes are denatured, then you won't be able to respire. Eventually, you may die. So because that is such a delicate balance, the carbon dioxide levels, the minute they increase even slightly, they kick in this whole mechanism that we have just discussed. Again, just to remember, the carbon dioxide levels increase, it drops the pH. This pH drop is picked up by special receptors, chemoreceptors in the carotid artery and in the medulla oblongata. Medulla oblongata acts as a control center. It sends messages to the diaphragm and the intercostal muscles to contract and relax faster. In simple terms, it increases the rate and depth of breathing. And what does this do? It gets rid of carbon dioxide from the body. The heart rate is also increased so that carbon dioxide from the cells are removed faster. In this way, the carbon dioxide levels comes back to normal. Notice nothing more different from what we spoke about last week. We've only changed the words, but the mechanism is the same. This one here is just showing you again to remind you of the nephron in the kidney. And it's this area here especially, where the levels of water are controlled. What happens in that area is sodium ions are pumped out of the tubules. So the sodium is positively charged, and chlorine will follow passively because it's negatively charged. So in other words, we're increasing salts in this area here around the tubule. So what have we done to the water potential of that area covered?
Decrease it.
We have decreased it. The minute you add solutes to a solution, you decrease its water potential. At the same time, if ADH is secreted, it causes this area here and this area here to be more permeable to water, meaning permeable, allowing water to pass through. So in that case, we will reabsorb more water, and the water will be back into the blood, and our urine will be more concentrated. That means there will be less water in your urine. If there's too much water, something else will happen. Now let's look at what happens here. Here's the water content of blood, which is normal. If you eat too much of salts, or you're sweating too much, this level of water can be low. Where's the control center? The pituitary gland. What does it do? It releases ADH. What does that do? It stimulates the reabsorption of water by the kidney, in the kidney. And therefore, we have a concentrated urine, and therefore there's more water into the blood, and therefore water level comes back to normal. If for some reason you're drinking too much of water and you're not sweating so much, then the water content is too high. Again, the control center doesn't change. It's still the pituitary gland, secretes less, or releases, less ADH, and because of this, low water reabsorbed, high water into the urine is dilute, less water into the blood, and therefore it comes back to normal. High, lower, low, higher. With that, to you, Luni.
I think it's time for a break now. Don't go away. We'll be right back. Welcome back from the break. Let's not waste any time and get straight back to today's revision lesson. Over to you.
Question 1 says, define the term homeostasis, Kaveh.
Well, it says maintenance and regulation of the internal environment as it is under the influence of any external stimuli.
Good. You see this boy, you better watch him.
clever.
Better watch him. Maintaining a constant internal environment despite any changes on the outside. So in other words, it's getting cold outside, but your body temperature will remain plus minus
37, somewhere there.
somewhere around
Yeah.
36
Degrees
to
Celsius.
37 degrees. Good. Okay. Name the internal environment of humans.
In what sense?
What is our internal environment? Where are the cells living?
Where the cells
My
live
first
in?
slide.
Yeah.
Which was that? Tissue,
tissue
fluid.
fluid, yeah.
You got that one wrong. Just mark it down in our book. One black dot on his name. Huh? List 4 factors that must be kept constant in the internal environment of humans.
Maybe temperature would be the pH.
Good.
Okay.
Good
More
enough.
than
Going in the
4.
right direction. Water, carbon dioxide, oxygen, salts, glucose, temperature, pH. Just on that note, let's just quickly talk about why. Why water? If there's too much water, you're going to get swelling in the body. The water is going to give you additional weight. There's retention of water. This can cause pressure on the kidneys, etc. If there's too little water, you'll become dehydrated. Good. Carbon dioxide. If there's too much carbon dioxide, what was the problem earlier we said?
The pH.
pH will drop, and that's going to affect the enzymes. Oxygen, if there's too little oxygen, your metabolic rate will be low. If there's too much oxygen, your metabolic rate will be too high. We don't want it that way. Salts, if there's too much salt in the body, your water potential of the tissues will be too high, you won't reabsorb water, and vice versa. Glucose, if there's too little glucose, you won't have enough energy. If you have too much glucose, you have sugar, diabetes. Right? Temperature, if temperature rises too much, it's going to affect what again?
Enzymes.
Enzymes, because high temperatures denatures enzymes, and low temperatures inactivate them temporarily. The same goes with pH, we spoke about that. Good. Explain how the concentration of carbon dioxide is regulated in the body of a person who is doing a lot of work for his team while playing soccer. Okay, from you, I only want to know what's going to happen to him. Is he going to have too much carbon dioxide or too little?
And obviously, he's playing. He's going to have too much of a carbon
He's
dioxide.
going to have too much of carbon dioxide. Excellent. Why? Because he's playing a game. He's running. His body is using. Respiration is at a high level. So too much carbon dioxide. So let's see what we're going to do. This is grade 11 work essentially, by the way. So what will happen is that the body will secrete less TSH first of all. B. This is one answer. This is one possible answer. But this is not what we wanted there. I must have left something in the wrong place again. I'm going to get wrapped on the knuckles. Okay, explain how the concentration of carbon dioxide is regulated. Kavi, you want to help me now?
Yeah, I can take that.
Because I got it 0.
Yeah.
Out of 7, I got 0.
Well, you'd say as right now you're playing soccer, right?
Right.
So obviously, remember in your body the metabolic rate of your cells and your cells go up.
Mhm.
Obviously, we're talking about cellular respiration.
Right.
So there's an increase in the production of carbon dioxide.
Right, so then what's going
So
to happen to
then-
pH?
Yeah. So your pH obviously now will drop.
So carbon dioxide up, pH low,
And
where it's
obviously
going to
then
be picked up?
in the hypothalamus, if I'm correct.
No, not the hypothalamus.
Yeah.
Which other part?
Your chemoreceptors will pick the
Yeah,
low
chemoreceptors
level, yeah.
will pick it up.
Then
And-
obviously the entire concept of homeostasis comes in.
That's right.
Yeah.
And that will go to the medulla
Oblongata.
oblongata.
Where your ventilation rate must now be increased.
That's right. Which will stimulate, increase
Yeah.
rate and depth
Of breathing.
of breathing.
Yeah. So now we're looking at your rib cage, your intercostal muscles. You're breathing at a faster rate.
Good.
Yeah.
So we're talking of the intercostal muscles, Kaveh says, and the rib cage and the diaphragm, all that's going to do that. So what we're going to do, this way we'll remove
More carbon
the
dioxide.
carbon dioxide, and the carbon dioxide will go back.
Yeah. And you're taking in
normal.
more oxygen.
Good. You're seeing the actual answer there. This one here is probably left over from somewhere. Gremlins in the system. Okay. Let's move on. A normal, this one here, you're going to have to read properly now. A normal blood glucose level is 1,0 milligrams per centimeter cubed. Normal insulin level is 0,5. A group of people with normal blood glucose and blood insulin were tested over a period of 5 hours. The average values were calculated and are indicated in the graph below. Okay. Before we go into this question, I want you to ignore these figures here because they just slipped in there. Okay, good. Now we'll be okay. Now we need to look at the graph and answer the questions. What are they telling us? Glucose and insulin levels in blood over time. Can you see the independent variable and the dependent variable are there? Time being the independent variable and the levels of insulin and glucose being the dependent variables. Therefore, they are found on the y-axis. And in this case here, you're getting both are there in that story there, right? So we're talking of blood, glucose, and plasma insulin there. The dotted line is insulin. There's your time in hours. Notice the units are given with the axes there. So when you're drawing a graph, remember the skills we need to transfer. Not only are we talking about the question, but also how do we draw graphs? Okay, so that's what we are talking about there. Notice that 1 to 2, 2 to 3, 3 to 4, 5, all equidistant apart. And the same here, 0,246. You can't make this 0,2 and make this 0,5 and so on. That's going to go off, so you won't get your mark for interval. What is the glucose level at 3 hours after the start of the investigation? 3 hours after the start of the investigation. So where must we go, Kaveh? 2?
First you go to your
3, right?
3, then
And then
go straight
go up.
Yeah. Then turn to your left and the
And go to
corresponding
that,
figure.
it's 1,4. And don't forget
The
the
units.
milligrams per centimeter cube. Good. Describe the relationship between insulin and blood glucose by referring to the graph. What can we say?
So the
As
time-
glucose increases, Kaveh,
insulin secretion
insulin
increases.
also increases. And what does this do? It causes a
Change,
decrease in the
yeah.
glucose level. That's what we need to say there. They just ask for the relationship in terms of the graph. Because look at the next question. Explain how the blood glucose level increases between 2 and 3 hours after the investigation starts, even though no food is eaten. Okay? Here's 2 to 3 hours. This area here, no food is eaten. How come the glucose level is increasing in this point here, up to there? What could have happened, Kawit?
Well, if you're not eating anything at that point in time, obviously the glucose level, there'd be the working of the hormones.
Which one?
Yeah, insulin, and you have your glucagon.
Glucagon, excellent. So in other words, glucagon would have been secreted because there's no food, and this is going to increase the glucose level. Notice you can't talk about insulin too much here because insulin is on the decline here. Okay? Good. Name the organ in the body which produces insulin. That's easy.
Pancreas.
Pancreas, good. Excellent. Okay, notice here, we could have asked you so much more still on this question here in the exams. We can talk about, explain the negative feedback that insulin is involved in. So you're going to talk about when there's high glucose level, this will be picked up by the pancreas, which will secrete insulin, and insulin will go to the liver in the blood and cause a change of glucose into glycogen and fat. It will also ask the cells, instruct the cells to absorb more glucose to be used, and this will bring down the glucose level to normal, homeostasis. Okay, good. Now we come to thermoregulation. Study the diagram below and answer the questions that follow. They're giving you a diagram of the skin. There's only 3 labels, A, B, and C. Okay. They want you to label layer C and part B. That was a giveaway already. Layer C would be the
Epidermis.
The epidermis. Good. Remember, that's the epidermis, and the rest would be the dermis. Okay? And part B. This one here,
Sweat gland.
that's the sweat gland. Remember, we have a sweat gland, then we have a sweat duct, and on the top will be the sweat pore. Those are the labels that you need to know. Everything around the sweat you need to know there. Okay, good. Describe the changes in the above organ when the outside temperature is 7 degrees Celsius.
Obviously, the body now needs to try to retain.
What type of, what are we talking about? Low temperature or high
There
temperature?
will be low temperature.
Low, obviously,
Yeah.
because our body temperature is around 36.
Yeah.
Okay, so you were saying, Kawen?
So obviously, the body will try to retain as much heat as possible.
Right? So what must happen?
So obviously,
First
there's-
of all,
yeah,
how does the body know about this change?
with the receptors.
Receptors
Yeah.
will pick up the stimulus.
Yeah.
In this case, cold. Body temperature has dropped. They send this message to
The brain.
hypothalamus, because in this particular thermoregulation, hypothalamus is the control center. The hypothalamus then instructs who?
With the sensory neurons.
No.
Yeah.
Which parts of the skin?
Would be the dermis.
No. You speak a little louder for us also, right?
Okay, yeah.
It's going to cause the blood vessels. I'm going to tell you which, and then you're going to tell me what it does to them,
Yeah.
okay? Sweat glands and the skeletal muscles. Okay?
Yeah.
Now you're going to tell me, let's put another color so we can make it easy for the listeners there or the viewers. But hypothalamus sends to the blood vessel. What happens to the blood vessels?
They need
It's cold,
to,
remember.
yeah, they need to constrict.
So we talk about vasoconstriction. Constriction.
Yeah.
Guys, vasoconstriction means the blood vessels to the surface of the skin become narrower. You can't say thinner and thicker. You must use the word constrict and dilate when we need it. So they will vasoconstrict, less blood to the skin, therefore less heat will go to the skin, therefore less heat loss by conduction, convection, radiation. To the sweat glands, are they going to be more or less active?
Less.
Louder, right?
Okay.
Less
Yeah.
active. And therefore you'll have less sweat.
Yeah.
And therefore less heat will be lost by
Yeah.
evaporation of the sweat. Skeletal muscles, what happens to them? They start to do what? They start shivering.
Shiver. Yeah.
And shivering has friction, and friction produces heat.
Yeah.
And we can add one more, the thyroid. More thyroxine,
Yeah. Increases metabolic rate.
metabolic rate up, and this creates body
Heat.
heat.
In-
Right, guys, we ended with the last question with what happens on a cold day. I just want to show you something very quickly here. Cold, and we did cold, so let's look at that one first. What did we say? That the stimulus is picked up by the receptor. From the receptor, it goes to the central nervous system, in this case to the hypothalamus. The hypothalamus sends messages. Blood vessels and skeletal muscles and sweat glands. If it's on a hot day, what's going to happen? Stimulus will be picked up by the receptors, and this will go to the CNS, that's to the hypothalamus. And what the hypothalamus does, it sends messages to the blood vessels, it sends to the sweat glands, and it sends not to the skeletal muscles in this case here, right? It sends to these two guys mainly. Okay. So can you see that your answer, Kawe, is the same in both, but the responses in each will be opposite to each other. Let's look at. Yes, I can maybe do that. Let's see. Blood vessels in a hot day will what happen to them?
Dilate.
They will dilate. And the sweat glands will be more active. Therefore, they will secrete more sweat, and the evaporation of the sweat will cool the body. Remember, you must say that last part, it will cool the body, or it decreases the temperature back to normal. Whereas on a cold day, the blood vessels constrict. The sweat glands are less active, and the skeletal muscles shiver. We can also add here the action of thyroxine. Increase the metabolic rate to raise the temperature back to normal. So that's an easy way just to remember the two. Remember, the one is the opposite of the other one.
We've come to the end of today's show. Thanks for joining me and for chatting to me during the show. Remember to visit our website, learn.mindset.co.za, to get the notes and to watch the videos from the term. Goodbye.